All right, today we are tackling a massive question, one that honestly sounds like it's straight out of science fiction, but it turns out science has a very real and very surprising answer. We're talking about something that gets to the very core of what our reality is. You've probably heard this one before, right? It's a pretty wild idea. The thought that everything you see, everything you feel, from the stars in the sky to your own thoughts, is all just an incredibly advanced computer program running somewhere. Well, it turns out scientists have a surprisingly firm answer to this. And, well, it's probably not what you're thinking. And look, this isn't just a philosophical daydream. Researchers like Dr. Mir Faisal have seriously considered this. The logic goes something like this. If you can simulate a universe, then that simulated universe could eventually get advanced enough to create its own simulation. You get this infinite chain, like Russian nesting dolls of realities. And if that's the case, statistically speaking, the odds that we're the original top-level universe are almost zero. But what if the whole idea is flawed from the start? Okay, so here's the big question. Can our reality actually be replicated by an algorithm? Researchers who've dug into this have come back with a pretty solid no. But the reason why has nothing to do with building bigger computers or having more memory. That's right. The roadblock isn't a tech problem we might solve one day. It's a fundamental wall built into the rules of math and logic. And to really understand why our universe can't be a simulation, we have to jump back in time a bit and meet the guy who discovered this incredible limit on what logic can even do. So back in the 1930s, a logician named Kurt Gödel completely turned the world of mathematics on its head. He came up with a discovery that sent massive shockwaves through math and philosophy, and as it turns out, it's right at the heart of our question today. To put it simply, Gödel's theorem says that any system of logic, a set of rules and starting assumptions, if it's powerful enough to do basic arithmetic, will always be incomplete. That means there will always be statements that are 100% true, but you can never, ever prove them using the rules of that system. It's just an unavoidable, built-in limitation. Okay, to really wrap your head around this, just look at this sentence. This true statement is not provable. Now, is that sentence true or false? Let's try to break this down, because it gets a little weird. It creates this fantastic little paradox. See? You're stuck in this perfect logical trap. If you manage to prove the statement is true, well, you've just contradicted it because the statement's whole point is that it's not provable. But if you can't prove it, then the statement is correct, which means it must be true. The only way out of this loop is to accept that the statement is true, but that it's unprovable from within your system. And this isn't just some clever word game. It's a fundamental property of how logic works. Okay, I know what you're thinking. What does some dusty old logic puzzle have to do with living in the Matrix? Well, it turns out it has everything to do with it. Because a computer simulation is, at its core, a formal logical system. It has to run on a set of rules, just like math. And this is the key difference right here. You have algorithmic systems on one side. That's a computer program. It follows a finite recipe, a set of step-by-step instructions. It's predictable. But on the other side, our reality seems to contain truths that are non-algorithmic. These are truths that you just can't get to by following a recipe. They require something more, something beyond pure computation. And hey, don't just take my word for it. Physicist Lawrence Krauss, who co-authored the study on this, puts it perfectly. He says to really describe reality, you need something deeper, a kind of non-algorithmic understanding. It's an insight that a computer program, by its very nature, can just never have. Now, this is where things get really interesting, because this whole idea doesn't just poke a hole in the simulation theory, it actually challenges one of the biggest, most ambitious goals in all of physics. Take a look at this. For really simple logical systems, like basic geometry, everything's great. They can be complete and consistent. You can prove every true statement. It's a perfect little world. But the moment you get to a system that's complex enough to do real physics, a system that includes all of arithmetic, that's when Gödel's theorem kicks in. The system is fundamentally, unavoidably incomplete. So that leads to a pretty heavy question, doesn't it? For decades, physicists have been chasing this holy grail, a theory of everything, a single, elegant set of equations that can describe the entire universe. But if the very mathematical language the universe is written in is incomplete, then a final, provable, computable theory might just be impossible. All right, let's take this one final step further into some really weird territory. If we know we can't prove every true statement in math, then how can we be absolutely positively sure that math itself is even consistent, that it doesn't contain some hidden contradiction? This is maybe the most mind-bending part of all. Gödel's work means we can't use math to prove its own consistency. We can never be 100% certain that the whole system of logic won't someday lead us to proving that, 1 equals 2. It means that at its very foundation, mathematics requires a little leap of faith. But of course, that doesn't stop us. As this quote gets at, science just keeps on going based on a really powerful and, so far, incredibly useful assumption that the universe is consistent. I mean, all of our technology, all of our ability to predict things, that's our evidence. It's a good working hypothesis, even if it's one we can never truly prove. So, let's just pull all of this together. What's the bottom line? Well, first, the universe probably isn't a computer simulation because its fundamental rules seem to be non-algorithmic. This also suggests that a final, provable theory of everything might be out of reach, and it reveals that science itself is built on this powerful, useful, but ultimately unprovable assumption that reality is consistent. And so I'll leave you with this final thought to chew on. If our reality can't be boiled down to a series of steps in an algorithm, if it can't be fully computed, what does that say about things like human consciousness or insight and what it really means to understand the universe we live in? Thanks for diving into this with me.